Hello. In this video, we are going to take a look at how we find the area between two curves. So we want to find the area of a region that is bounded by curves f of x and g of x on the interval a to b. If f and g are continuous functions with f of x bigger than g of x on the interval a to b, then the area of the region bounded by the curves between f of x and g of x and the lines x equals a and x equals b is the integral from a to b f of x minus g of x dx. So what this is saying that if I have two functions, we have f of x and we have g of x. Make g of x look like it's doing something a little bit different. Between x equals a and x equals b. If I want to find the area of this region blocked off, then to do so would be to take the integral from a to b of f of x, which would go all the way from the green function down to the x-axis. And then subtract the integral from a to b of g of x, which is taking the area under the red function down to the x-axis. So taking all the area, subtracting the lower function's area, leaves us with just the area between the two curves. And properties of integrals tell us we can turn a subtraction of two integrals on the same interval into one integral with subtraction. So this area idea follows from integral rules, but also want to see how we can use the formal definition of integrals to set up this same rule. So using the formal definition says, suppose I take an interval, a to b, and I divide it up into n subintervals. And I pick out a spot in there that we'll call xi star. Then, if we specifically want to find the area of a little rectangle at xi star, that will look like this little rectangle drawn out at xi star is going to be f of xi star minus g of xi star will give the height, and the width is some tiny little interval of x, delta x. And so the area at xi star is equal to just what I said, that height being the upper function at xi star minus the lower function g of x I star times that little bitty distance delta x. Now there's one of these rectangles at every spot along this interval. And so I could take all of those and add them up. So taking all the intervals, there's n of them. of our A xi stars, which is now going to be the sum I equals 1 to infinity of f of xi star minus g of xi star times delta x. Right now, we have little rectangles where a little bit of the rectangle is over and a little bit of the rectangle is under the function, and this is just an approximation. To make this area, that is the sum of all these rectangles, more precise, we want to make that width of the delta x as small as possible. And that is then taking the limit as n goes to infinity of this sum of the area, f of x I star minus g of x I star delta x. You may recognize from help 1 of this setup being that formal definition of the integral. So as we take the limit of the sum, we get the integral from a to b of f of x minus g of x, and the delta x becomes our dx. So using those formal definition of the integral, we get that same definition for the area between two curves. In the next videos, we'll look at some examples of using this definition.